When it comes to fabricating your model with one of the 3D printers available at the KTH Architecture School workshop, the main limitation to take into account is the maximum dimensions. The maximum dimensions possible to print in the 3D printers is 200 times 200 times 200 millimeter. So if you select your intended geometry to print and you type bounding box, and then you see here that this particular model is with the meter units, and it's 35 times 35 times 152 meters in dimensions. So this particular model would only be suitable to 3D print in a scale of 1 to 1000 or even smaller. Of course, you could max out the maximum dimensions and fabricate a 200mm high model in a scale of 1 to 760, but that's not a very standard scale. So take into account the maximum dimensions possible to fabricate with the 3D printers at KTH Architecture School workshop, 200 times 200 times 200 millimeters. Alright, we'll delete this bounding box. It is important to deliver the actual file to be 3D printed in a millimeter unit file document in the intended scale of fabrication, and thus one could recommend to save the file as a separate file. So let's see here, and this will be in 1 to 1000 and in millimeter units. Very good, let's save it. Okay, now we can make significant changes to the model without having to worry about altering the original one. Alright, so the first thing we can do is to change the units from meter to millimeter, going to unit settings here. And then since the intended scale of fabrication would be 1 to 1000 in this particular case, we could simply, when changing units from meters to millimeters, we could simply keep the geometry unscaled, since changing units here would incur a change in scale of 1000, and then we would scale down with 1000, so that would be the same. But since this is only applicable in the 1 to 1000 scale use case, we will show now like for any use case. So change it to millimeters, click OK, and scale the model by 1000, since that is the factor change from meters to millimeters. Yes. Alright, and as you see, it was significantly scaled upwards, but we can actually, already at this point, we can simply Control A to select everything, and then we could of course ZS to zoom to selected. Alright, here we have our model, but we would not actually need to have done that. We could simply scale with everything selected, type the command scale, and the base point should be the origin, most easily input by simply a single 0. And the scale factor should be 1 divided by 1000, or 0.001. Enter to confirm. And then we can ZS to zoom to selected again. Now when we type the command bounding box, we should see here that the bounding box dimensions are now in millimeters, and it's about 35 times 35 times 152 millimeters. So in a scale of 1 to 1000, this model could be fabricated with the 3D printers at KTH Architecture School workshop. Alright, I'll simply undo this command with Ctrl Z. And your original model might rely on separate geometries for separate material handling, but the model that you should export and deliver to Henrik in the architecture workshop should be delivered as one file, one object, and it should be closed. So in this particular case, we have already 2 closed solid polysurfaces, but we should select both of these and BooleanUnion these. Very good. The reason for this is to allow the Ultimaker Cura software to make the most efficient slicing of the model. And if we zoom in here and go inside of the model, now here is the BooleanUnion state of affairs, but if we undo this, you see here, if I press escape to deselect it as well, you see here that we have an exterior surface that is co-aligned to an exterior surface, and this might be a problem for the Ultimaker Cura software to efficiently slice, even though it would be no problem as long as the tolerance is suitable enough. But I'll redo that command with Ctrl Y, And now you see here that we have no exterior surfaces co-aligned to any interior surface. Alright, as previously stated, this should be a closed solid polysurface. It can also be a mesh, but then the same restriction apply. It must be a closed mesh. So if one would type mesh here to make this a mesh, and if one would select that last generated geometry, then you see here that this is a closed mesh. If you would explode this, then you see that there are 9 open meshes, and this would not be able to be even processed by Cura, by Ultimaker Cura, the software used in the architecture workshop to slice the models for 3D printing. So they should be closed. If I join these meshes, it's one closed mesh. Very good. The same thing applies here for the BREP surfaces. They should be a closed solid polysurface. When we export to the STL format, any BREP surfaces, any surface geometries will actually be converted into mesh geometry, but you can use BREP geometries and then it will be automatically converted to STL mesh when exporting. The 3D printers used for fabrication at the KTH Architecture School workshop can handle overhangs, that is when an area or when a portion of the geometry is situated above void. You see that there's an overhang here. The overlying geometry extends beyond the underlying geometry. And the 3D printers can handle up to about 50 degrees of overhang, so significantly more than the overhang we have here. They can handle up to about 50 degrees overhang without having to generate supports for the overhang geometry. But if you have a geometry or a portion of it that extends in a much more protruding angle, then you will need to generate supports. And generating supports is no problem at all. One only has to be aware that if the 3D printer is to print not only the model but also support geometry as well, then that will incur an addition in time it takes to print, as well as an increase in material cost. If you have several objects that you want to 3D print, it is very important that you export these objects one per each separate file. So if you would have as well here a small box, then it is important to export these 2 separate closed objects separately. When exporting multiple objects separately, it is no problem if the additional geometry is situated in another position than centered around the origin. Ultimaker Cura, as long as you export the different geometries separately, import it in a way which allows Henrik to place it individually and correctly on the 3D printed printing bed. But remember to export separate objects separately. Alright, to export the intended object for fabrication as an STL file, you simply click on the object, make sure that it's a closed solid polysurface or a closed mesh. If you haven't already, make sure that when doing the bounding box command that it's less than 200 times 200 times 200 millimeters, the maximum dimensions of the 3D printer. I'll undo that. With it selected, simply type export. This is the same command as one would otherwise click File and Export Selected. Alright, export. And here you will export it as an STL file, a stereolithography file. So scroll down here and stereolithography, STL. And then to make it easy to overview for Henrik, you can save it as name, perhaps your name, and then perhaps some sort of signifier for your project, tutorial in this case. And then I usually, just to make sure that the scale is imported correctly, I just take note of the height of the model, which is 152 millimeters. And then when Henrik imports it into Ultimaker Cura, there you can immediately see if it was imported as 152 millimeters in height, or if it was imported as 152 meters in height, then that of course would not be possible to fabricate anyway, but just to make it easily verifiable that the scale is correct. Alright, for the options here, you want to have it as a binary file. It is simply smaller in file size. And here you also see that by default open objects are not even exported, so make sure beforehand that all the objects are closed, otherwise they will not be able to be sliced in Ultimaker Cura. Okay, and then save. And then the tolerance 0.01 millimeters as a default is adequate. So we can click OK. This is the tolerance for the generation of the mesh that will be created for the stereolithography file. OK. And then you see here an approximation of the size that it will be, a very small file in this case. Click OK. And now it is exported. If you had several objects that you intend to fabricate with the 3D printer, you simply repeat the projects for those additional objects. So selecting that, export, then we can click that one to get that name, but then change it, of course, so as not to overwrite it. And then this is the box, and it was, I think it was 11.3 millimeters. And generally, one should avoid decimal points in the file name, but in most cases it is only the file suffix, the last characters after the last point, that will be interpreted. But one can also make sure to simply replace it as an underscore here. All right, and for the options, yes, it's the same. Okay, save, and okay, and okay. Very good. Now we have those two. Then to easily go here, we can simply copy that directory there and go to File Explorer, and there, and here we are in the exported directory, and here we have these two files. And since this one was only used for demonstration, I will delete this. This is the one that we were interested in. The next step is to actually deliver the file, the STL file, to Henrik for verification, so that he can make sure that the object can be fabricated with a 3D printer. Either walk down into the architecture school workshop, or send them a message on Facebook, or for actual delivery of the file, preferably you would email Henrik immediately via this email with the file attached. He will then be able to import it into Ultimega Cura, check how long it would take to 3D print it, how much it would cost, and then he can get back to you. And given that the model is adequately prepared, you can visit on site the architecture workshop to make an actual booking with Henrik. And when you make a booking, you write down your name and your telephone number so that you can be easily reached should a problem occur or anything happen. And if you during booking have not decided upon anything else, it's important to be on site on the date of the actual 3D printing no later than 10 AM. Otherwise your booking will expire and someone else might be prioritized. The student pays for the material cost that it costs to fabricate with the 3D printer your model, as well as a 50 krona fee per booking. The material cost starts at about 3 krona 42 öre per meter, so that of course depends upon how large your model is, but the 50 krona fee is fixed per each booking. If it turns out to be a very long print, they are preferably run over the weekend, starting Friday after lunch. You will know already at the moment of booking how much your print is going to cost, including the booking fee. But it is generally paid after the print has been completed, so that you would not have to require a refund if any initial problems occur. Thus, you usually pay after the print has been fully completed. The price might vary significantly depending on the model that you are actually 3D printing, as well as inclusion or exclusion of supports, of vertical supports. But as an example, this model here, it cost 211 krona to fabricate, but that's just a reference. Your mileage may vary.